Everybody. Again, my name is Nicole Forsyth. I wanted to welcome you to our webinar today, How to Overcome the Obstacles of ST2110 Infrastructures. I just had a few housekeeping items to go over with you. I wanted to let you know that the webinar will be recorded and you will all receive a copy of the VOD once it's ready. And if you have any questions, please use the chat panel and address your questions to all panelists. That way, we will all get the questions and we will be able to answer them during our Q&A session. Also, for ultimate viewing, optimal viewing during the webinar, I suggest that you push Control-Shift-H, and that will allow you to see the two presenters side by side. I wish you all a good day, and I hope you enjoy our webinar. At this point, I'd like to welcome Francesco Scartosi and Willem Vermoost.
Hello, everyone. Hello and welcome. Thank you all for joining us here today. I'm very happy to see we have a large and diverse audience from broadcasters to system integrators and manufacturers as well. I think one thing we all share in common here today is our interest in the 2110 technology. It's interesting to all of us here because we can start seeing the broadcast industry starting to take a step into the future of IP. So I'd like to start off by thanking our very special guest here, Willem Vermoost, who has agreed to be interviewed. Hi, Willem.
Hey, Francesco.
And Willem is here to share with us his knowledge regarding 2110 environments and some common challenges that we are all faced when bringing up these environments and how to best overcome it. So the format is the interview with Willem will be followed by a Q&A session, like Nicole said. So please definitely feel free to put your questions as they come to you in the chat window so we can get to them all at the end. So let's begin. Willem, for those in the audience that don't know who you are, why don't you tell us who you are and what do you do?
Well, there's a lot of people, so just let's get started. So my name is Willem Vermoost. I work in broadcast since 1999. I started off as a support engineer at the Flemish radio and television. And a few years ago, I saw a fantastic idea popping up. You know, years ago, we changed from these tapes that we would be running through the corridors here to file-based production. Very nice. And then I thought, well, how long will it take whenever we move live into IP? And actually, a few years ago, I saw a nice position opening at EBU exactly for that spot. And I thought, well, this is a perfect match. So 4 or 5 years ago, I moved to Switzerland, to Geneva, to join EBU and to start actually looking into the move from SDI to 2110. We didn't even have the name 2110 at that moment, so it was very nice.
Cool. Well, that's a good overview. So it's also safe to say that you have been deeply involved in the JTNM tested program, right? And for the audience members who might not know and not be familiar with that program, can you briefly describe the program itself and how important it really is to the industry as a whole as we move towards 2110?
Well, that's a big question. I'll try to give a good summary here. So first of all, JTNM stands for, that's actually a summary, or let's say, of AMWA, the VSF, the Video Services Forum, EBU, the European Broadcast Union, and SEMTI. So those 4 organizations are coordinating all the IP efforts in a body that's called JTNM. Now, from an EBU perspective, we saw that many of our members of our broadcasters are moving to new buildings because they had buildings from the 60s and they should move. And suddenly I saw 2 opportunities coming together. First, the move from SDI to IP and the need for a lot of users in order to decide where to go. Should we go IP? Should we stay with SDI? So that's a very important part. And then I was at all these interop tests. And I saw there's a clear opportunity to move beyond interop tests because the standards will at a certain moment It's done, it's finished, it's out. To move from interop tests to real tested programs, to see the equipment that's out there on the market, if it really conforms and it's interoperable. So this serves as well the industry as it serves our members as well.
Okay. And I understand that the JTNM event that was to be taking place earlier this year in the spring was to also include an element of self-testing and a week-long face-to-face validation session. Obviously, due to the unforeseen circumstances of COVID-19, the face-to-face portion of the event was canceled, right? In your opinion, Willem, does the self-tested program or portion of the JTNM program become more important going forward? And if so, why?
Well, I think to this question, there are probably two answers. So 2110 is just not one document. It's a full stack or a pile of documents. There's the base document, -10, 20, 21, and so forth. So the things that need to be tested grow. The amount of products on the market grow as well. So of course, if you want to scale this, at some point you need to rely on self-testing, right? We didn't have the intention to do as much as we did due to the COVID pandemic. And then you start to bump into things that you think, if you do this self-testing, well, how would you do it? And how would you be sure that once you move to self-testing, that everybody's using similar tools and similar kind of things, just to be sure that the results are comparable? And that's a major topic. Yeah.
And what kind of test and measurement tools do you think are fundamental for successful self-testing?
Well, it's like a black box. Whenever you want to test something, you need to give it some input and you need to look at the output, right? And see if this is really what you want to have it like. So this being said, we need to have an input to devices. So we need to have generators, that's for sure. And not just a steady state generator, but maybe something to create all those multiple frame rates. I hear in the States and Canada, maybe also they're still doing fractional frame rates. I don't know why. It's very complex stuff you have there. There's multitude of resolutions. And the move to IP helps us not to just produce into one thing like HD. Maybe for the news you want to have HD, but maybe for a fiction you want to have UHD. So it should change from format to format. And there are a lot of things that you can tweak on the go. So that's the promise. So you need to have generators that are very flexible in creating all those different formats. Also tweak them a little bit, because the thing we never could have done in SDI was to test receivers.
Right.
Yeah. We only had the eye pattern in the nice equipment, but that's it. So you need to be sure that receivers are working well. So therefore, you need good generators. On the other hand, you need to have devices to read the output and to see if it's really conformant with the specifications.
Right. Yeah. So kind of to paraphrase what you're saying is ultimately the generators would have to be able to simulate a bunch of different devices, really, because it's not realistic to have, a good representation in a lab of every piece of equipment that you might be faced with. So if a manufacturer actually successfully completes their self-testing, does that mean that the broadcaster, who's ultimately the end customer of these equipment, right, who are looking to build 2110 environments, does it mean that they would not need to test their equipment in their environment at all?
I should start laughing now. No, it's not because somebody else tested it and says, yeah, you can trust me, here it is, off you go. That's maybe reason number one. But besides the trust, of course, when you get something, you should build an official report if it's good to go and good to put into your facility. That's probably rule number one. Please do check it before you start operating it. Now, there might be a second thing to this as well. If it's in operation, and God knows I've been in operation at the start of my career, it was very strange at that time. It was, is it running? Is it working? Then don't touch it.
Right.
But now we're moving into software, right? So it's similar like this type of equipment that everybody knows, the smartphone. Yes. From time to time you get an update and you expect that the thing still works. Well, actually in broadcast it will be the same. We're moving more and more to software. So maybe within operations, you need to check from time to time that those parameters still are relevant. With each update, you need to check those things.
Right. That's a very good point. So when a given broadcaster's actually decided to build a 2110 environment, do they only really have to consider testing the environment and equipment at the very beginning? I mean, to say the one-off test versus continuously testing, you're saying mostly it would be a continuously tested program, if you will, because of the fact that there are things that change within the environment.
Because of updates, and maybe you plug an extra device. Well, will the extra device work with the whole environment? Just to be sure that those things are still aligned. I think we're moving besides continuous deployment into continuous testing as well.
Right. Okay, perfect. Now, in this next portion, I would like to maybe do a little deeper dive into the details of the 2110 specification. I know a lot of people on the call here today, in the webinar here today, are aficionados of 2110. So maybe we're going to get into areas that people are aware of on a very surface level, but I want to really dive into highlighting the certain parameters of 2110 and the importance of why we want to test for them, and more importantly, why we want to stress them. So let's start with the role of NMOS and what role it plays in 2110, and specifically in test and measurement devices. And do you think it's a requirement that those devices should support ISO 4 and ISO 5?
Well, again, very good question, and maybe I'll describe it very high level first. If you would have a telephony system without a dial, without the possibility to dial up, you have these ladies in an old telephony central, right, that need to patch cords. Well, 2110 is just like that. And it's a lot of work and it's cumbersome if you want to connect a sender to a receiver. With NMOS on top, you have a control layer, and this would actually facilitate, my apologies, this would facilitate all these configuration and manual things. So NMOS, yes, that's very much needed to have more or less a complete system.
Okay, good. And how would you recommend testing the flexibility of the 2110 devices in terms of the ability to receive different variations of the 2110-21 parameter? In your answer, I really want you to touch upon what VRX is and why it's important. I know maybe some people might know about it, like I said, on the surface, but really dive into what it is and why it's important.
Okay, so let's scratch the surface a little bit here. And this actually, if you look at all the documents of 2110, there's a very specific document. And for me personally, that's the cornerstone of the whole solution. If people read it, they will start laughing at me because I say this all over the world. And it's -21. -21 is the cornerstone. And from a really high level, moving from SDI to IP, well, there's one thing that we did change, that's the network. And we changed from a very reliable, robust, we know it all, SDI network into an IP network. So we need to be sure, in order to have a reliable solution, that the IP network and the things that we connect to it remain reliable. Therefore, we need to be sure that the buffers within the network and the buffers of a receiver are not oversubscribed or overflooded with traffic. -21 describes 3 parameters. There's one about nonlinear and linear flows or gapped flows. Let's put this aside for the moment. But there's something called C, the C buffer level. The C buffer level, that's a buffer level that is a parameter in order to be sure that you're not overflooding any buffers in the network. And well, to make an analogy, it's like filling a bottle of water. If you fill a bottle of water, you typically have a funnel on top. And if you pour the water in too fast, the funnel overflows, right? Well, the same can happen in a network. Then if the funnel overflows, the buffer of the switches do overflow, packets get dropped, and your solution is not reliable. Now, at the receiver side, you have a buffer as well. That's the virtual receive buffer. That's VRX, which is described in the standard. Now, it's the same funnel. You pour the packets into the funnel. If the funnel overflows, packets are dropped at the receiver side. That's not the way to go. So you need to pour them in at a certain pace, and the funnel gets drained at a certain pace. And the difference between the C buffer model and the VRX buffer model is at the receiver side, you're synchronized with the PTP clock in order to get the packets at the pace that you really need them for the application to display them again.
So basically having a test and measurement device that could actually help you tweak that parameter to test not only the flow, the inflow, but also make sure that it's actually draining properly to see how it fits in your environment is a crucial step, I guess.
Yeah, there's the fun, of course. So you have wide receivers and narrow receivers. And the wide and the narrow, well, that's actually representing more or less the buffer size of the receiver. So if you have a wide sender, which is more loose in the packets that are placed on the network, then it won't fit into the narrow.
Right.
But what are the limits to the system? You need to be able to tweak and to find the limits of the system just to be sure that you remain to have a reliable system at the end. So
exactly.
These are the interesting points to figure out.
Yeah. So let's continue in the deep dive and look at another important parameter, RTP timestamps. So they're used to synchronize media. Why does this parameter need to be tested, and what kind of tests would you like to see assess a device's performance with regards to timestamps?
Well, of course, once you get into 2110, you have all the flows in a different stream. There's the audio, there's the video, there's the ancillary data. But at some point, you need to combine them again, and they should be synchronized, right? You expect the voice to be synchronized with the lips here, lip sync, very important in broadcast. And this is why the RTP timestamps are used. So, of course, you want them to be reliable and to be able to synchronize your video and your audio again. Now, in those interrupt tests, suddenly I discovered that there was a device that was not sending the RTP timestamps correctly. It was just sending zeros. And at that moment, I thought, well, it's interesting. The receiver end is just doing nothing with the RTP timestamps. It just displays it. So how would it synchronize? Now, I tend to say that maybe graphical devices, they shouldn't care about it unless there is audio synchronized to the graphic, of course.
Right.
So this is a very important one to see how a receiver reacts to whatever you do with a timestamp. In the audio part, there's a small difference between IS67 and 2110-30, and there's an RTP timestamp offset that's possible or plausible within IS67. In 2110-30, it's constrained to an offset of 0. So those corner cases, you just need to be sure that they're right. Otherwise, you come to nice surprises.
Yeah, like you're saying, I mean, ultimately, 2110 gives you the flexibility of sending video, audio, and metadata all separately. So, being able to reset and in different paths, right? And being able to receive it and resynchronize it on the receiver end, and making sure, like the case you mentioned, nothing seemed to be wrong because audio and video are coming in, but they're off. And in graphics, especially since I'm an NFL fan, sometimes they're putting graphics up with a swoosh. So you don't want to scare your audience when you're seeing something, and then a second later you hear a swoosh. It's like what's going on?
Yeah.
So
maybe it was the ball. You never know.
Yeah, exactly. So let's move on to EBU list. I think something that you might know a little bit about. I'm not too sure, but EBU list has become a very well-known tool in the context of transitioning to 2110. And as one of the parents of List, I think you might have some really good insight in how you think it's contributed to the industry.
Well, I've seen it grow. So, yes, I'm aware of EBU List. Actually, it started as a PowerPoint and an Excel. The moment they were starting to think about 2110, and then the process was ongoing in SMPTE, at some point each week there were other formulas in this -21 document. So I was working a lot to get those formulas right each time, again and again. And then at a certain moment I thought, God damn it, Willem, you're lazy. You're an engineer. You should be more lazy to this. So I started to do something in Python and to start reading out the PCAP files, check the RTP timestamps and that sort of things. And then I I met Pedro Ferreira, who's a very nice guy, and he said, well, of course, it takes a long time to run through all these PCAP files. You should do it in C++. But actually, he briefs C++. So actually, then he's the lead developer now on EBU list. And then he made the core libraries in C++, and all the rest on top is Java and those standard things. And from the interoperability tests towards the tested events, we developed this as a really standard tool that every vendor just could use in order to analyze those things up front and come really with good equipment. So I think it's beneficial for the vendors because they could improve the quality and the maturity of their products. It was good for EBU to get to know what 2110 was about. And at the end, it's better for our broadcasters as well, because we get mature products on the market.
Of course. Now, EBU list requires network traffic to be captured in order to perform its job, right? PCAP files are the most common way of capturing a stream for analysis. Is it simple to capture PCAP, a good PCAP file? And what are the problems you saw, whether you experienced in JTNM, that people were facing when trying to do so?
I should say, first of all, yes. Well, it should be simple, but you should take care of a few things, of course. I mentioned earlier on PTP. For those who are not aware, PTP, that's the clock that runs over IP that will replace your black burst. But the PTP has an accuracy within the nanosecond range. So if you use just your regular Ethernet board on your PC and you start to capture, it's not accurate enough. So in order to have a good and accurate capture, to measure and to do all the math to figure out VRX and C and that sort of stuff, you need to have an Ethernet board that does an accurate timestamp. So the PTP clock and the timestamping should really be on the Ethernet board itself. Right. Otherwise, you don't have a good PCAP file and you're not able to measure anything.
Yeah, you're not actually taking a proper representation of what's in the veins of your environment. Yeah. So that's great. And that brings us to the conclusion of the interview. We've touched upon many points, many important points from the JTNM tested program, the importance of an adjustable 2110 signal generator, and how that actually helps from broadcasters to manufacturers, system integrators, PCAP recording, and the EBU list tool. I hope that the audience has found this information that we shared here today very informative. And before we jump into the Q&A session, just want to ask you, Willem, do you have any questions for me?
Well, I really would have hoped to ask you a question, to be honest, and not just the weather this time, but no, I've seen that one of your colleagues, Jean, he was there from the early beginnings, probably before me, I don't know. He was there at every interrupt test and every JTNM tested program. He's even part of the JTNM experts group building those test programs. Now, as a manufacturer of 2110 equipment, what are the insights that you gathered from the tested program?
Yeah, and let me give props to Jean. Jean is one of the biggest brains we have at Matrox. I lovingly refer to him as the Great Gazoo. And for those of you in North America know that I'm referring to something very good. It means he has a big brain. So yes, it's true. And Matrox has invested a lot. Jean and his team and a lot of engineers have invested a lot of time in early development of 2110, even before the spec was ratified. We've developed multiple generations of 2110 NICs, and during that time, our labs were being filled with a bunch of homegrown tools that basically enabled internal validation so that we could ensure that we had a solid product, but it also helped us ensure successful EBU result, JTNM tested program results. And the truth is that these tools were built out of necessity. I mean, and they've actually played a very important role in developing our solutions. What became clear to us once we went into these interops and JTNM program was many of our industry colleagues were facing similar challenges. And not only the manufacturers of 2110, but also talking to, the broadcasters, we realized that the industry could actually benefit from these tools. You know, and so what we did was we packaged it in a 1RU appliance, which we call the Matrox VERO. And I'd like to jump into it. We have my colleague Michael Kempner online. I'd like to just jump in for a couple of minutes just to give a quick overview of what VERO is, and then we'll jump right into the Q&A.
So, hello everybody. Let me just make sure that everybody can see our Matrox VERO. So, the Matrox VERO itself is controlled by an easy-to-use web GUI that can be accessed by any modern web browser on any device on your network. So, after logging into the Matrox VERO, you will find yourself on the dashboard that gives you access to the main features of the Matrox VERO. So, we have the signal generator that allows you to send 2110 flows to your meter network. We have the PCAP capture that allows you to capture the actual traffic on the wire that's coming to the Matrox VERO device, and EVO list that allows you then to directly analyze those PCAP files that you capture. Additionally, we have some other options on the dashboard that allow you to look into the status of the Matrox VERO and some additional settings that you can do with it. So first, we will want to look into how to generate flows to make them available on your media network, and how easy it is to make changes to these flows and save any changes to additional sender profiles that would reflect exactly the scenarios that you're looking for your tests. So for this, we can immediately go to the signal generator. On the signal generator, on the drop-down menu, you can select any of the predefined sender profiles for the Matrox VERO that you want to play out. And the general enable button of a channel will then send those media flows to your network. If you're, for example, only interested in the video flow, you can then disable all the other -30 and -40 flows to only have the video flow being sent to your network. You can also make immediately changes in the signal generator to your current flow. For example, you can change the resolution, the multicast addresses, but I want to focus more on the actual sender type time. So currently we're sending out a narrow flow, but I can change this to a wide sender flow, which would then reflect the wide sender type specifications of simply 2110-21 to be able to test your receivers on the network if they can handle such types of flows. So once you acknowledge those changes, you will then immediately update the GUI so that you actually know what's being sent out currently to your network. You can then save those changes directly to a new profile, and you can then go to that profile to also make additional changes to fine-tune this sender profile to what you want to send out currently on your media network. So this was a quick overview about sending data to the network. Now let's look at the PCAP capture. So for the PCAP capture part, you can add and fine-tune any sender sources that you might have on your network. Simply clicking on them will enable those sources by sending join commands to the switch so that we can actually receive the traffic on the Matrox VERO. And capturing the PCAP file is just a simple click away, and you will find then the captured PCAP file in your capture jobs. And there's a link that will link directly to the EVO list that's installed on the Matrox VERO to be able to analyze the PCAP files that you just captured. So in this case, we actually see that we have an error flow that's compliant with simply 2110-21. And you can see that this flow, which is actually coming from a Matrox VERO device, is a very excellent flow for a narrow specification. So this concludes the quick overview of the Matrox VERO, and I'll hand it back to Francesco and Willem.
Thank you very much, Michael. That was great. So, Willem, are you ready to field some questions? We have a few here, so let's just jump right into it. One of the questions is around PCAP, and it's basically asking, you know, would you be able to just let me read it. What can we just use? System network connection to run a PCAP capture. Okay, so the question is basically, why can't I just use any system with a network connection to run a PCAP capture? And what makes VERO any different than that? So effectively, I'll field that, and feel free to add any comments, Willem. But capturing PCAP file of 2110 signal can be difficult. I mean, when dealing with uncompressed 2110-20 video, data rate could be quite high, especially if you're going to be in UHD, right, at 5994. The bandwidth hovers around 11 gigabits per second or 1.4 gigabytes per second. So not only do these captures require a high bandwidth capture to disk without packet loss, but they also require a high precision timestamping for proper post-analysis for compliance. So both are not easy to accomplish, like we kind of touched on before, without specialized equipment. So I hope that answers the question. Would you like to add anything there, Willem?
Well, I think a few years ago, I still remember it was January. Pedro and my previous colleague at EBU, Yevgen, we thought, let's write a paper for NAB about how to capture. And we tried another Nick that's famous in this industry as well. And to be honest, I think it's quite difficult to be sure to set it up and that you have accurate results. And every time there's an update of the driver or the whatever, you need to retest the system and be sure that it's accurate, etc. So if there's a pre-built system, sounds very good to me. You can build it, but there's a lot of work that comes with it in order to be sure that it's always accurate, always spot on.
Right. So that there's another follow-on to that. So that question was more about why do we need specialized equipment to capture PCAP reliably? But there's another one that I'm reading here is once I capture PCAP using a network card, can I then pass it to an analyzer like Wireshark?
Yeah, that's a good one. And yes, of course you can. And then you can start digging into the details of RTP and marker bits and whatever you want. And if you want to do this live, by the way, we do have a lot of students in master classes. And each time I say, well, good luck with this, because the data is passing by at a rate maybe at 3 gigabit per second. Mm-hmm. So live Wireshark, it's not an option. For debugging, yes, it is. This might be something like List, because this is sits in between the scope you're using right now and sits between Wireshark. Mm-hmm. It's a tool perfect to do the job because it abstracts all the details within Wireshark and it gives you directly the link to the SMPTE standards. Otherwise, you need to interpret all those things yourself. So yes, it is possible, but it will give you a lot of work.
Okay, that's great. So there's another question, I think that, and this came from the portion where we did the deep dive. So somebody even wants to dive even deeper. So the relationship, they're asking about the relationship between PTP and RTP timestamps, and just explain a little bit more about that relationship.
Yeah. Are you sure you want me to go there?
No, they asked the question.
So PTP, that's an 80-bit number. So 80 bits, that's quite a lot. And it gives you nano precision seconds from the 1st of January, somewhere in 1970. So that's a lot of precision. An RTP timestamp, that's just 32 bits. So how to stuff 80 bits into 32? Well, it doesn't work. So the RTP timestamp, it's a number and it increases compared to a clock rate. For audio, this would be 48 kilohertz. For video, it would be 90 kilohertz. So you can imagine that if you have a clock rate at 90 kilohertz and it ticks each time one up, increases by one the RTP timestamp, at a certain moment, it wraps around. So the 32 bits, they can represent a certain amount of time. Then you need to know at the current PTP clock, what's the current time. You can calculate how many times the PTP timestamp, the RTP timestamp wrapped around. So modulo is your best friend while you're doing this. And the rest, the remainder, that's actually what's written in the RTP timestamp. So you can actually you can do this as a nice, pleasant exercise. if you have a Wireshark and a PCAP file, you look at the RTP timestamp, the PTP clock, you can do the calculation between them. And actually it works.
That's great.
I hope it was enough. I can take this offline and go more in depth if you wish as well.
We can definitely do that. We know who asked the question, so we can get back to them. But I think that was a great answer. Thank you. So the next question sounds like somebody is actually read into VERO, so I'm happy to see that. In your data sheet, you seem to make a big issue about supporting key. What's so special about key in 2110? So key has always been carried as a video in SDI, right? And it's very wasteful since there is no real color in key signals. 2110 defines key only signal. So VERO supports both legacy de facto way of carrying the key signal and the real 2110 defined key. So proper key in 2110 brings advantages like lower bandwidth usage and identification methods as well. So that's why we thought it was important to highlight that in our in our specs. Okay. Let me see here. Somebody noticed in Michael's demo the interface is a web GUI. It's on purpose. Effectively, the GUI, as you can see, is very intuitive, very easy to use, but it's also easy to access. So because it makes the most sense in IP environments, I believe, it allows us to use access to the unit from anywhere and any devices, so it could be actually repurposed easily and allow multiple users to take advantage of it, like we showed briefly, but that Michael was setting up certain profiles from different users. So that's actually something quite cool that we put there. Let me see if there's any other questions. I know we've gone. Let me just see here. Scroll. Okay, is there any NMOS server you would recommend at the time for a test environment? Don't know if you want to field this one, Willem.
Well, there are a few out there that you can just download and get started with. If you want to compile it, you have options. If you don't like to compile it and you just want to download a container and get started, there are options as well. There are some even big companies, I don't want to mention the Japanese name, but they made a server completely in C++, very powerful. You can just download it and start it up. There's a German company, don't want to mention the name. There's an individual at a company that builds NICs that made something available. They're all usable, they're all tested, they're very good. Just pick one. If it needs to be powerful, I would try to go for the C++ version. So that's the first thing I was trying to mention. And those are available there for free, and just get them up and running, and off you go.
Perfect. Okay. And as we get to the 45-minute mark, I think this is going to be the last question. So, how does VERO compare with existing tools? So I can't really talk about other tools. I can really talk about what makes VERO unique, and I think we touched upon it a little bit today. So the fact that we're fully adjustable, not only does it send a narrow or wide, it allows you to really test the boundaries of the spec, which becomes important, like you had mentioned also, when more and more software becomes used, so software receivers and so on. Also going beyond the spec, right? It's important to see how equipment reacts when you break the specification, right? So allowing you to break it. And the fact that, like you had mentioned, Willem, that we do various HD, not only 720, 1080, but we go even to 4K. So it's one device that you could actually use to simulate a lot of a different assortment of senders. Okay, so that's key. I think that another important point would be the integration of the the ability to capture PCAPs and use EBU within the tool, quite easily, like Michael showed, is important. The GUI, like we showed, is very easy to use and accessible. And the last thing I would say would be, it also can be automated via a REST-based API, which will be available soon. This is key because ultimately, you maybe, like you said, Willem, you want to maybe set up the stuff at the broadcaster where you're continuously testing to make sure that your environment, your equipment is robust and actually doing what you're expecting to do. So it's important to have that automation as well. So that go ahead.
I'm already dreaming about a lot of possibilities here. Maybe overnight, when we didn't schedule our studio to be working, we can automate the tests of all the senders and all the receivers and get the results. I would love this.
One thing I didn't mention is that you've also been an early adopter, one of our friends in the industry. So we actually put a VERO in your hands. What did you think about the unit?
Well, I'll be very honest here. No, seriously. I received the box and thank you for that. And I thought, well, let's give it to a guy from our lab. He doesn't know anything. He doesn't know what I was doing last year. So I just gave it to him. And I said, well, the only thing I need to know is how much time it takes to get it up and running and for you to configure it so we have a working system here. And I kid you not, it was out of the box and it was in the rack, and then it was up and running in 5 minutes. We went to the interface and he started just clicking and it was very intuitive. If you would compare this to equipment we got maybe last year, a year ago, you had to type in every detail everywhere, very deep in the interface. The VERO box is quite intuitive. And now together with the NMOS implementation as well, it will be super. Yeah, so I think our lab guys, they're very happy to have it.
Good. No, I'm very glad about that. And Willem, that concludes the webinar. I really appreciate your time. I hope that this was great for the audience members. We have a lot of people, like I said, diverse from broadcasters, system integrators to manufacturers. So I think that we did. I think that we did a service to the 2110 community, and I hope that if there's any further questions, please feel free to reach out to us. And you could do so by just sending an email to BMG Broadcast Media Group at matrox.com. That's again, BMG at matrox.com. Thank you for attending. Thank you once again, Willem. Have a great day and stay safe.
Thank you, Francesco. Ciao, everyone.
Ciao.